So the first thing we want to do is draw a picture of the objects before the collision and label a coordinate system. So our car beforehand is going north of east, and it's going to collide with some other parked car. So this is before. So we're going to label the moving car, car A, and the parked car, car B. So we now need to label our coordinate system. In the problem, we're given north of east, so let's define east as our x-axis and north as our y-axis. So this is what it looks like before the collision. So then we want to now go to step 2, which is draw all the objects after colliding in our same coordinate system. So if a car is moving north of east and hits something that is stationary, what will happen is they'll continue moving north of east. So after our collision, the angles aren't going to change. We have car A, car B moving together inelastically north of east. So we have our x-axis east and our y-axis north still. So now we need to assign a mass and a velocity to each object before and after the collision. So object A before has a mass of 1,000 kilograms, and its velocity, we have our theta here, is 20 degrees, and its velocity is 30 meters per second. So its velocity is 30 meters per second with a theta of 20 degrees. Car B has a mass of 2,000 kilograms, and its velocity is 0 because it's parked. So we now need to look at our final velocity. After we have A plus B collided together, the total mass of this is 3,000 kilograms, and the velocity is our unknown that we're trying to solve for. So our next step is to break down our velocities into their respective components. Here we have an x and y axis, but our velocity is a hypotenuse of a triangle. So if we draw our triangle, we have Vx, Vy, theta, and this is 30 meters per second. So our Vx for A is 30 times cosine of 20 degrees, which I've pre-calculated is 28.2 meters per second. Vy is 30 times sine of 20, which is 10.3 meters per second. B, since it's not moving, we already have everything done. Its velocity in both the x and y directions is 0. So I'm going to put that up here. Vx equals 0, Vy equals 0. So after the collision, we also have unknowns, but we need to break them down, right? Vx is equal to question mark, and Vy is equal to question mark. So the goal is to find Vx and Vy, and then use the Pythagorean theorem to find V, right? So now our next step is to find the total momentum of the system before and after in every direction. So we have to do each direction by itself. So let's do the x direction first. So in the x direction, the momentum of A is mass of A, so 1,000 kilograms, times Vx, 28.2, plus the mass of B, 2,000 kilograms, times 0. So our total initial momentum is the sum of these two guys, which is 1,000 times 28.2, which is 28,200 is our initial momentum. In the y direction, we have 1,000 times our Vy, which is 30 sine 20, plus 2,000 times 0. So that is 1,000 times 10.3, which is 10,300. So now we have our initial momentum, Pix, and our initial momentum, PIY. So we now have broken it down into all its components. So we now need to find the final momentum in our directions. But that's really easy because it's unknown, right? So our final momentum we're just going to call it PFX and PFY because that's what we need to solve for. So we now need to use the law of conservation of momentum, and we can set the initial PIX equals PFX and PIY equals PFY. And then we just use algebra to find our answers. So if we scroll down, we get PFX is 28,200 and PFY is 10,300 because of the law of conservation of momentum. And I'm just going to label that for space reasons. So PFX is 2820. So what is PFX if we write it out in terms of its mass and velocity? That's the mass final, which if we go back here is 3,000, times VFX is 2820, or 28,200. So VFX is 28,200 divided by 3,000, which if we go to our calculator, 28,200 divided by 3,000 is 9.4 meters per second. So now we can do the same thing with y. PFY is also 3,000, which is the mass of the final system, times VFY. That is equal to 10,300. So VFY is equal to 10,300 divided by 3,000, which is equal to 3.4 meters per second. So our final velocities are 9.4 meters per second in the x direction and 3.4 meters per second in the y direction. So if we go back to our picture, we know that it's going this way, 9.4, and this way, 3.4. But that's not quite the final answer. What we need to do now is use the Pythagorean theorem to find the final, which is the hypotenuse of that triangle. So I'm going to go over here, and V final squared is equal to V final x squared plus V final y squared. So V final squared is equal to 9.4 squared plus 3.4 squared. So 9.4 squared, if we plug it into our calculator, is 88.36. Apologies. 3.4 squared is 11.56. So that plus 88.36 is 99.92. And the square root of that, so VF squared is this, VF is the square root of 99.92, and that is 9.96 meters per second. So the final velocity of the cars after they've crashed moves at 9.96 meters per second.